Hello friends, now we are in JE Cloud and this is your Cloud Mentor Gavarish. Today we are going to discuss some problems from units and measurements of physics, and let's look at the problems. Yes, the first problem is that the SI unit of electrochemical equivalent is dash. Electrochemical equivalent, we know that from the electrochemistry, and it is electrochemical equivalent is denoted by Z, and we have the equation that is M is equal to ZIT. M is equal to ZIT. There is a mass of the substance liberated or deposited, and from this we are going to do this problem. Here, according to the Faraday's first law of electrolysis, that is M is equal to ZIT, or MIT is Q. So ZQ, and here we need to find the electrochemical equivalent of or the SI unit of electrochemical equivalent. So Z equal to M by Q, and we know that the unit of mass is kilogram and unit of charge is coulomb. So kilogram coulomb raised to -1, which is the answer. So option C is the right answer. Yes. So let's look at the next question. The sum of numbers 436.32, 227.2, and 0.301 in appropriate significant figures is options are given. Here the sum of 436.32 and 227.2 and 0.301 is that we get 128.3 6 and 6. So 663.821 is the sum, and we need to write it in the appropriate significant figures, because figure in this sum, we know that 8 is more than 5. This 8 is more than 5, so 1 is added. 1 must be added to 663, and the answer must be, that is 663 plus 1, so answer will be 664. So option B is the right answer. Next question. The sextant is used to measure option A, area of hill, B, height of an object, B, C, breadth of a tower, and D, volume of the building, which is the right answer. The sextant is used for measuring the height of tree, building, tower, hill, or such things. And so from the options, we can say that option B is the right answer, that is height of an object. Sextant is used for measuring the height of an object. Okay, and now next question. You measure two quantities as A equal to 1.0 meter plus 0.2 meter, B equal to 2.0 meter plus or minus 0.2 meter. We should report correct value for root AB. So here A equal to 1.0 meter plus or minus 0.2 meter, and B equal to 2.0 meter plus or minus 0.2 meter, and here X is, we can say that the quantity root AB as X equal to root AB, and which is equal to root of, I am taking the absolute values, not taking the errors, that is 1.0 multiplied by 2.0, and that will be equal to root of root 2, that is equal to 1.414. Okay, yes. So we need to round off, we can round off this value to 1.4, so that is equal to 1.4. So x equal to 1.4 because it is less than 1, right? Yes, so 1.4 is the x value of x. And now we have to find the combined error from this. So that is, we know that x equal to root ab, and that's equal to 1.4. Root ab can also be written as ab the whole raised to, or ab the whole raised to 1 by 2. So the error in this can be found by the equation delta x by x equal to the raised to 1 by 2 taken down, that is 1 by 2 of delta a. 1 by 2 is common for a and b, so we can take 1 by 2 as common, and that is delta a by a plus delta b by b. And the delta a by a and delta b by b is the absolute error here, that is which is given here and here. So applying that, we will get delta x by x equal to 1 by 2 of delta a is the error given here, which is that yes, this is the given error. So delta a equal to 0.2 divided by a is 1 here, a is 1, 1.0, and plus delta b is the error 0.2, the same 0.2, and b is 2. So doing the problem, we get 0.6 divided by 2 multiplied by 2.0. okay, that's it. So delta x will be equal to 0.6. Delta x will be equal to x comes here, or x is multiplied to the 0.6 by 2 multiplied by 2, so that will be equal to 0.6 by 2 of 2 multiplied by x. The value of x we have got here, that is 1.4. So multiplying that, and the sum of this 0.6 by 4 will be equal to 0.15, and that multiplied by 1.4, 414 or 4, that will be equal to 0.2121. So rounding off, we get delta x will be equal to approximately 0.2 meter. So our final answer must be root ab must be equal to 1.4 meter plus or minus 0.2 meter. 1.4 meter plus or minus 0.2 meter. So let's look at the answers. 1.4 plus or minus 0.2 meter. So this option D is right answer. Option D is right answer. So moving to the next question. A pressure of 10 raised to 6 9 centimeter raised to minus 2 is equivalent to. Here the options contains the Newton and meter, which are the SI units. So we have to convert dyne and centimeter to the SI units. So we know that 1 Newton is equal to 10 raised to 5 dynes. And from this we can write 1 dyne as 1 dyne will be equal to 10 raised to minus 5 Newton. And we know that 1 meter is equal to 100 centimeter, and we can write centimeter, 1 centimeter as 10 raised to minus 2. 100 can be written as 10 raised to 2, so 1 centimeter will be equal to 10 raised to minus 2 meter. So we can now convert the given value, that is 10 raised to 6 9 centimeter raised to minus 2, which is equal to we are multiplying 10 raised to 6 multiplied by 10 raised to minus 5 Newton multiplied by 10 raised to minus 2 meter the whole square, 10 raised to minus 2 meter the whole square, and that's equal to that's equal to here so it will be 10 raised to 1 or 10 raised to minus 4. Oh, 10 raised to, here it is in centimeter raised to minus 2, so here it must be minus 2. So 10 raised to 6 and 10 raised to minus 1 minus 5, that is 10 raised to 1 here, and 10 raised to 1 and 10 raised to plus 4, so 10 raised to 5, 10 raised to 5 Newton meter raised to minus 2. Newton meter raised to minus 2 is the answer. So option A is the right answer. Option A is the right answer. So let's go for the next question. The universal time is based on which of this one? So we know that, or it is a fact that the time defined in terms of rotation of the earth is called the universal time. Okay, it is based on the, or it is defined by the, universal time is defined by the rotation of the earth, this universal time. Okay, rotation of the earth on its axis. So option A is the right answer. Now next question. Which of the following cannot be regarded as an essential characteristic of a unit of measurement? So here the option A is inaccessible. The unit must be inaccessible. Uh, let's come to that. The second option is indestructibility. So if we define one thing as the unit of a measurement, then it must not be destructible, it must be indestructible. So that's a property of the, or characteristic of unit. And the second, invariability, yes, that must be, must not change with time or the space. And the option D is the reproducibility. Yes, that unit must be reproducible if it is destroyed by any case. So option A is that inaccessible. How can we use an inaccessible thing as the unit of measurement? So option A cannot be regarded as the essential characteristic of the unit of measurement. Also option A is the right answer. And now the next question. Young's modulus of steel is 1.9 multiplied by 10 raised to 11 Newton per meter square when expressed in CGS units of dyne per centimeter square. It will be equal to dash. So it is a conversion. So we know that here Young's modulus is given as 1.9 multiplied by 10 raised to 11 Newton per meter square. So here we need to convert the SI units to CGS units, and now we know the conversion factor that is 1 Newton is equal to yes, 10 raised to 5 dynes, 10 raised to 5 dynes. And we know that 1 meter is 10 raised to minus 2 meter, minus 2 sorry, 1 meter is equal to 10 raised to 2, 10 raised to 2 centimeter, 10 raised to 2 centimeter. That means 1 meter square will be equal to 10 raised to 4, 10 raised to 2 the whole square, that is 10 raised to 4 centimeter square. So we can now convert. So in CGS the value will be y equal to 1.9 multiplied by 10 raised to 11 is already there, and multiplied by converting to Newton. So converting to dynes, we need to use 10 raised to 5. Okay, so 10 raised to 5 dynes divided by, in the denominator it will be centimeter square. So that is 1 meter square equal to 10 raised to 4 centimeter square, 10 raised to 4 centimeter square. So that's it. Solving, we get 1.9, 10 raised to 11 and 10 raised to 5, that is 10 raised to 16, and 10 raised to minus 4 comes upward, so 10 raised to 12. So that answer will be 1.9 multiplied by 10 raised to 12 dyne per centimeter square. So let's look at the options. Option C is the right answer. Option C. Moving to the next question. Which one of the following pairs of quantities and their unit is properly matched? Electric field with Coulomb per meter, B, magnetic flux with Weber per meter square, power, farad, capacitance, Henry. Here the option A is wrong. It is not coulomb per meter. It is Newton per coulomb. Newton per coulomb, or otherwise it must be volt per meter. So that's wrong. That is wrong. And now, yes, the magnetic flux is the unit is Weber per meter square. So it is right answer. So option B is right answer. And for power it must be watts, okay, watts. And in the case of capacitance it must be farad farad. And Henry is for the inductance. So option B is the right answer. Now moving to the next question. It is raining outside. I don't know if you can hear me. Okay, option next question, that is the mean length of an object is 5 centimeter, which is the following measurements, which of the following measurements is most accurate? Here we have the options and we need to find the difference between this value, this mean length, and all these values. And that is the mean length x equal to 5 centimeter, 5 centimeter. And the first one, that is option A, that is delta x1. Change difference can be written as delta x1, that is 5 minus 44.9, and that is equal to 0.1 centimeter, 1 centimeter. And delta x2, which is of the second option, that is 5 minus 4.805, which is equal to 0.195 centimeter, 195 centimeter. And delta x3, and which is equal to 5 minus 5.25, 5.25, and that's equal to minus 0.25 centimeter, minus 0.25 centimeter. And delta x4, which is the option D, equal to 5 minus 5.4, that's equal to minus 0.4 centimeter. So the which is the most accurate or the most closest to value. So the difference must be the least one. The option A is the right answer, because 0.1 is the least one from all these options. So option A is the right answer, which is the most accurate measurement. And next question, energy per unit volume represents which one of the quantity? Energy per unit volume. We can do it by using the dimensions, that is energy per unit volume, energy per volume, right? Volume. Simply for energy we know the ml square formula is ml square t raised to minus 2, and divided by volume, that is v l cube. So that will be equal to ml raised to minus 1, ml raised to minus 1, t raised to minus 2. So we now know the answer, that is pressure. Pressure will be equal to pressure will be equal to force per meter square, that is force is mlt raised to minus 2, and that divided by meter square, that is L square. So that will be ml raised to minus 1, t raised to minus 2. So energy per unit volume is otherwise called the pressure, or it is represented by pressure. Both have the same dimension formula. Now next question, which of the following pairs of physical quantities does not have same dimensional formula? Yes, the work and torque. First one is work and torque. Next it is angular momentum, Planck's constant, tension and surface tension, impulse and linear momentum. Here the work and torque both are the product of force and length. And the tension and surface tension, okay, so tension, which is the same as of the force, that is mlt raised to minus 2 for tension. and surface tension will be force per length, that is ml t raised to minus 2 by l, that is m l raised to 0 t raised to minus 2. And impulse and linear momentum, impulse is the change in momentum, so they have the same, and work and torque also have the same dimension formula. Tension and surface tension does not have the same dimension formula. And we have forgot angular momentum will be equal to the moment of inertia multiplied by moment of inertia multiplied by angular velocity, and that's equal to the moment of inertia, the value of moment of inertia, that is ml square, and dimension formula also angular velocity, that is t raised to minus 1, so that is equal to ml square t raised to minus 1, ml square t raised to minus 1. And for the Planck's constant, that is energy per frequency, energy divided by frequency, that is equal to ml square t raised to minus 2 divided by t raised to minus 1, and that will be equal to ml square t raised to minus 1. So that is also having the same. So the option C is the wrong formula, or not having the same dimension formula. And that is the right answer. Moving to the next question. The surface tension of mercury is 32 dyne per centimeter. Its value in SI units is, you have to convert it to SI. Same conversion we can use here, that is one dyne is equal to 10 raised to minus 5 Newton, and centimeter, 1 centimeter is equal to 10 raised to minus 2 meters. So that will be, tension will be equal to 32 multiplied by 10 raised to minus 5 divided by 10 raised to minus 2, and that will be equal to 332 multiplied by 10 raised to minus 3 Newton per meter, Newton meter raised to minus 1. So that will be 32 multiplied by 10 raised to minus 3 will be 0.032. Okay, 0.032. So option A is the right answer. Next question. And the relation y equal to r sine omega t minus kx, the dimensional formula of omega by kr, we have to find. Here we know that omega t is the angle, and angle is having no dimension. This dimensionless quantity, so omega t is equal to 1, and omega will be having 1 by t, that is t raised to minus 1, and also kx is also the angle, so it is also dimensionless, that is 1. So k will be equal to, we have to find omega by k, so that is k will be equal to 1 by x, and x is the length, so 1 by l, and that's l raised to minus 1. So for omega, dimension formula, so omega by k will be omega. For omega we can write t raised to minus 1, and for k we can write l raised to minus 1, and l raised to minus 1 taken upward, that is lt raised to minus 1 will be the answer. Or m raised to 0, l raised to 1, and t raised to minus 1. So let's look at the options, that is option B is the right answer. Option B is the right answer here. So next question. 1 light year is defined as the distance traveled by light in 1 year. Yes, the speed of the light is 3 multiplied with 10 raised to 8 meter per second. The same in meter. Wow, same in meter. That means 1 light year in meters. 1 light, not 3 multiplied with 10 raised to meter per second in meter. It is the 1 light year represented in meter. We have to find that, as we know that that is the option B, but I am now showing how it comes. That is 1 light year is can be found out. 1 light year will be equal to 3 multiplied by 10 raised to 8 meter per second multiplied by 1 year. And now 1 year must be converted to seconds. That is 3 multiplied by 10 raised to 8 meter per second multiplied by 365 multiplied by 24 multiplied by 60. That is by multiplying by 365 we got in days, and multiplied by 24 we got in hours, and multiplying by 60 we got in minutes, and again multiplying by 60 got in seconds. Okay, so that will be equal to 3 multiplied by 3 multiplied seconds and second. Here now got in seconds, so seconds and cancel, so that will be doing we get 9.461 multiplied by 10 raised to 15 meter. So option B is the right answer. Next question. One slug is equivalent to 14.6 kilogram. A force of 10 pound is applied on a body of 1 kilogram. The acceleration of the body is. So here you know that F is equal to ma, that is force is the product of mass and acceleration. So A equal to, we need to find the acceleration of the body, so A is equal to F by m, and we know that F is 10 pound here, so 10 pound per mass is 1 kilogram, so 1 kilogram, and we can now write the pound as slug feet per second square, slug feet per second square. So that is we get 10 slug feet per second square. And now we know that one slug it is given that one slug is equivalent to 14.6 kilograms, so we can apply that here. So that is 10 multiplied by 14.6 kilogram, 6 kilogram feet per second square, and that is 146 feet per second square. And here 1 feet is equal to 0.3 meter, so that is we get 146 multiplied by 0.30 meter per second square. Second square raised to is raised to upwards, that is -2, and so that will be equal to 44.5 meter per second square. So answer option 44 point meter. So option A is the right answer. Option A is the right answer. Now next question. If the acceleration due to gravity is 10 meter per second square, and the unit of length and time are changed in kilometer and hour respectively, the numerical value of acceleration is dash. So that's a good question. Here it is changing from, the units are changing from length or meter and second to the kilometer and hour. So we know that the conversion, that is n to n1 u1 is equal to n2 u2, n1 u1 is equal to n2 u2, or otherwise we can use the formula that is n2 equal to n1 multiplied by L1 by L2 raised to A, and m1 by m2 raised to B, and t1 by t2 raised to C. So here we can use, we have only two quantities, that is length and the time. So that is n2 will be equal to n1 of L1 by L2, L1 by L2. Here it is meter per second, so here A is 1 and A is 1 and B is -2, so in the case here it is 1, and now t1 by t2, t1 by t2 the whole raised to -2. So that's it. We can apply the n1 is the 10 here. This is the numerical value, first numerical is 10, and now 10 and L1 will be equal to 1 meter. L1 is meter, L1 is meter, 1 meter, and L2 is kilometer. 1 kilometer into meter, we can say that is 10 raised to 3 meter. 10 raised to 3 meter. And second, and the time is second. 1 second is in the first unit is second, and to the hour, 1 hour is 3600 second. 3600 seconds, and that raised to minus 2. So meter cancelled, second cancelled, and 36 multiplied by 10 raised to 2. 3600 we can write 36 multiplied by 10 raised to 2, and that when comes to top it will be 10 raised to minus 2 and 10 raised to minus 4, and we get 10 raised to 2. So that will be equal to, we get after calculation we get 1000 or 1,29,600. So that's the answer. So option D is right answer. Option D is the right answer. Now next question. 1 AMU is equivalent to 931 mega electron volt energy. The rest mass of electron is 9.1 in 10 raised to minus 31 kilogram. The mass energy is mass energy equivalence. That is 1 AMU, given that 1 AMU equal 1.67 in 10 raised to minus 17 kilogram. So we have to find the mass energy equivalence. First we have to find the mass of the electron. Mass of the electron. The mass of the electron, which is compared to we have to compare this mass of the electron to the AMU. So mass of the electron will be equal to 9.1. We know that 1 AMU is equal to 931 electron volt. So we have mega electron volt. So we have to convert this mass of the electron to AMU. So 9.1 multiplied by 10 raised to minus 31 kilogram divided by 1.67 multiplied by 10 raised to minus 17. Yes, minus 17 kilogram. So cutting them, and we get the drop there, and now we can find the energy equivalence, that is E equal to 9 point. We must multiply this value, this much AMU multiplied by 1 AMU have this much mega electron volt energy, so multiply this value to this. Okay, so we get 9.1 multiplied by 10 raised to minus 31 divided by 1.67 multiplied by 10 raised to minus 27. Minus 27 here, it is wrong, it is minus 27. Okay, minus 27 kilogram, and multiplied by 931 mega electron volt. So by calculation we get it is equal to 0.5073 mega electron volt. So option A is the right answer. Option A is the right answer. Next question. The value of universal gas constant is R equal to 8.314 joule per Kelvin, Kelvin mole, and the value of R in atmosphere liter per Kelvin per mole. So what is that? So here also we can use the same formula, and R equal to 8.3 joule per Kelvin mole. And now N1 U1 equal to N2 U2, and here U1 and U2 are the units, while N1 and N2 are the numerical values. And now N2, we have to find the N2, that is numerical value. N2 will be equal to N1 U1 by U2, that is equal to 8.3. N1 is 8.3 and U1 is joule per Kelvin per mole, Kelvin mole, and so that divided by u2 will be equal to yes, atmosphere atm liter per Kelvin per mole, so Kelvin per mole. So that's it. Now we have to find the value that is it is gone, and now that is 8.3 joule divided by, and converting atm to newton per meter square or joules, it is 1.013 multiplied by 10 raised to 5 newton per meter square, and in the place of liter we can write 10 raised to, it is 10 raised to minus 3 meter square, so meter cube. And now we got, it is 8.12 divided by 10 raised to 2, and that's equal to 0.0812. So let's look at the options. 0.0812, so option D is the right answer. Next question. Electron volt is the unit of energy. This 1 electron volt equal to 1.6 multiplied by 10 to minus 19 joules. And in hydrogen atom, the binding energy of the electron in first orbit is 13.6 electron volt. The same in joule is which of the following? And given that 1 electron volt is 1.6 multiplied by 10 raised to minus 19 joules, and here we need to find 13.6 electron volts, so that will be equal to 13 electron volts equal to 13.6 multiplied by 1.6 multiplied by 10 raised to minus 19 joules, and that will be equal to 21.76 multiplied by 10 to minus 19 joules. So option B is the right answer. Next, we can take the next questions in the next part. Okay. And to know more about the Cloud Mender, visit our website. You can Google by typing Cloud Mender Gaurish. Site appears as the first result, and or simply search Cloud Mender and you will get the site as the third result. And also you can follow us on different social media platforms, and you can follow us on Instagram, and you can follow on WhatsApp. I have created a WhatsApp group for discussions on different doubts you have, and the links are given in the description box. Also a Telegram group for discussion and the same purpose, and a channel is also formed for giving off your learning steps, and all the links are given in the description box. You can check it later. You can also ask your doubts as comments in YouTube, and if you want more videos which would be uploaded in the coming days, please subscribe our channel and press that bell icon for getting notifications on time.
Hope you guys understood the topic. Thanks for watching my video. Always be free to ask questions. Subscribe to my channel for more videos. If you like this video, share it with your friends. See you guys.